You bet. As I promised, we were going to do the lab walkthrough for the Windows command line lab to get familiar with it. And kind of a fun little lab for people to start learning how Windows as an operating system works, especially whenever you're looking at it from an incident response perspective in your organization as well. So the first thing I'm doing is I'm starting up my Kali terminal. And then we also open up a another terminal for PowerShell. And we'll do that here in a second. Let me turn this to bold 18. There we go. Then we'll open up a PowerShell terminal. And as I mentioned, we're disabling AV because once again, the goal of this lab isn't, how do you bypass AV? The goal of this lab is what would be the methodology that you would use and the tools that you would use to be able to detect malware on a Windows computer system. So we're going to disable that AV now, and then we're going to go to disabling our firewall so the two systems can talk to each other. There we go. And then we're going to set the administrator password to password 1234. By the way, don't ever make that your password. Just don't do that. And then I'm going to get my IP address and I'm going to set my little Windows window off to the side so I can still see that IP address over there, like so. You can see it's 1010, 234, 223, so on. I'm going to become root on the window or on the Linux system. And then I'm going to start MSF Council. All right. So MSF Council is kind of the main gateway for utilizing the Metasploit framework. And everything that you do kind of ties into Metasploit. So if you're using like MSF Venom, that's wrapping two separate tools, at least in the past, MSF Venom and MSF Payload together into one framework. And you can do all of that through MSF Council. There's also different GUIs that exist for Metasploit. In fact, Cobalt Strike actually started as a full GUI for the Metasploit framework, and they kind of parsed that out. I will load that report into Discord. Just give me a second. People want it. I'm going to put it in resources if that's okay. So let me go here. Let me go upload a file. And I'm going to do a search for Fernando. There we go. And the report that you asked for has been delivered to the resources section. So you have that ready to go. And it's still not loading. And the reason why is Metasploit is like the world's largest Ruby environment. There's a tremendous amount going on under the hood of the Metasploit framework as well. So just kind of waiting for it to start. And whenever we get started up, just kind of walking through, we're going to be using the most heavily used exploit in the Metasploit framework. And this particular exploit is called PSExec. And PSExec actually was a tool that was created by a gentleman by the name of Mark Rusanovich a number of years ago. And what it does is it allows you to remotely authenticate to a Windows computer system and execute commands, generally used as a systems administrator tool when working and administrating Windows environments. So we're going to use that exploit, even though it's not an exploit. We simply use a user ID and a password. Now, it's very common for people to say, well, I get that, but how often do you actually get a user ID and password in a Windows environment? And the answer is a lot. At the end of this lab, one of the things I'm going to show you is how I don't actually have to crack password hashes in Windows environments in order to leverage the access I have to gain access to other systems. PSExec supports the capability of utilizing hashes instead of a password. So I'll demonstrate that here in a couple of seconds. We're going to set the payload to be Metasploit Meterpreter reverse TCP. Then we're going to set the R host, the remote host. We're going to set it to our Windows computer system. My Windows computer system is at 10.10.234.223. That's my remote system. We're going to authenticate to that system. And then we're going to set the SMB user to be the administrator account. Then we're going to set the SMB password to be the password 1234. Okay. There we go. All right, then we're going to run exploit, and that is going to launch our malware. Actually, what it's going to do is it's going to remotely authenticate to the Windows computer system. Once it is authenticated to that Windows system, it's going to start a service. That service is going to reach back, grab the actual malware, shove it directly into memory on the Windows computer system, then delete the service and delete the initial file that it dropped onto the computer system. And we have an interpreter prompt on that computer. So now we have full access to that computer system. I can see the files on that computer system. I can look at the processes on that computer system. I can run keystroke loggers, key scan underscore start, like that. Key scan. There we go. Now I've got did I mistype that? I got two dashes. There we go. So now I've got a keystroke logger. I'll come back to that here in a couple of seconds. I have a lot of really good stuff running on this computer, but it's full malware. And now we're going to get to the actual point of the lab where we're going to go through and we are going to actually detect that malware on the Windows computer system. So what? There we go. That looks fine. All right. So we got our command prompt a little bit bigger. It's easier to see. And the first thing we're going to start is we're going to start with those network connections. As I was talking about yesterday, it is absolutely essential that we start by looking at network connections. And the reason why it's so important to start at the network connection is because we need to start somewhere. And if I'm looking at the processes on a Windows computer system, if I go back here and I do PS, there's a lot of processes, and trying to hunt down something when you got 45 SVC hosts becomes exceedingly difficult. So what I like to do is I like to start with the network connections and work backwards. Now we have a lot of these ones at the bottom where it has colon, colon, and it looks like, it's just like a couple of colons, kind of looks like a butt. Those are IPv6 addresses. That is the local loopback for IPv6 on those. So we want to go up and we want to focus on anything that is established or SYN-sent or possibly closed. All of these are listening, but you can see I've got a bunch of established Elastic agents because I'm running Elastic on this particular VM. And then if I keep going, I'm eventually going to see I'm going to see my back door. I got to look for the port that we have here, which is 4444 right here. And you can see that this particular backdoor is running PowerShell and it's shoveling a connection to my Linux computer system on 10.10.227.222. Now, that port is modifiable. You can totally take that particular port and you could change it to something that would fly under the radar, something like 80, or pulling down something like 443 on that as well. It is actually the Elastic agent for that. It's actually one of the open source, or not open source, one of the free instances of Elastic agent. And the server on the other side is dead. The new version of this server doesn't have it moving forward. But we can see that backdoor. But I also have the process ID. So I'm going to go ahead and grab Notepad on this system. And I'm going to copy this. All right. So I'm going to copy this and I'm going to paste it into Notepad because I want to get that. I want to get that process ID right there, the 4764. So we have that ready to go. We can start drilling into that particular process ID. I can also run netstat -f to see if everything resolves on the system as well. We can do that. Question is, can we do that on our own systems, on our own network to check the environment, to check our systems? You absolutely can. All of these commands that we are running, you can run on any Windows computer system. There's nothing that's going to break them, most likely. All right, so if I look down here, I've got a bunch of different resolved IP addresses. I've got SSH, I've got my terminal server. If we're looking at these particular connections, this is the only one that doesn't really jive all that well. And that one is, once again, our backdoor with Metasploit going to our Linux system. So now let's dig in on that particular process ID. All right. So now I'm going to put in the process ID that I saved over in Notepad, which is 4764. So I'm going to put that in 4764, like so. And now I can see the dynamic link libraries that are utilized on that particular backdoor. All right, let's talk a little bit about those dynamic link libraries. I'm going to open up another command prompt on the system. All right. I'm going to go ahead and pull these over because I need to see my Linux IP or my Windows IP address. Pull that one in, and I'm going to CD into Intro Labs. I'm going to netcat listen on port 2222. Oops. Netcat listen on port 2222. And when somebody connects, I'm going to execute cmd.exe. Right. So I just created a little backdoor. I'm going to open up another Kali prompt on this system. And I'm going to connect to it. I'm going to go netcat to 10.10.234.223. All right. And as soon as I connect, oh, wait, 223 port 2222. There we go. And whenever I connect, I immediately have a backdoor. All right. Now, I want to go through the exact same steps that we did with our Metasploit system as I did with this really, really simple little netcat backdoor that I just created out of thin air. So if we're looking at this, I can go back to that netstat NAOB, right? And we're going to get the process ID for our netcat system. Okay. So we're looking for 2222. Did I miss it? I swear, sometimes it's the easiest stuff. There it is right here. All right, so we've got this one on port 2222, and I've got the process ID is 7132. All right, so let's do the same thing, but now we're going to look at the netcat process instead. So what we're going to do is we're going to do a look at that particular process ID for a netcat listener. Oh no, it didn't copy. Oh, I completely forgot what it was. All right, so let's go up and get the process ID again. Some people remember things and they type things down. I'm not one of those people. Right, there it is. 7132. So I should have followed my own advice. I'm going to copy this and I'm going to paste it into Notepad. Here we go. All right. So we've got these two separate malicious backdoors that we have created. So now let's look at the dynamic link libraries. There we go. There we go. So we're going to look at the first dynamic link library for our Metasploit session right there. And now we're going to change that process ID for our netcat session. And that one is 7132, 7132, like so. And look at that. They're the same. So what is my point in looking at the dynamic link libraries and like highlighting that we have two pieces of malware, one that we created with Metasploit, another one that we just set up basically on the system using Netcat. And for those of you that don't know, Netcat is one of the oldest backdoors that has ever existed on a Windows computer system. It's been around for a really long time, right? So the dynamic link libraries that are required for malware to function, the core dynamic link libraries are these dynamic link libraries. ntdll.dll. Wow. Does anybody know what whoa is? What do we have there? We got wow D64, wow 64 base, wow 64 win, con, and CPU. That's Windows on Windows. That's 32-bit compatibility. But we see those same dynamic link libraries being used in both situations, right? Does that mean that it's always malware? No. It doesn't necessarily mean that it's always malware. It just means that it's another kind of indicator. I will be honest with you. I haven't ever seen a system or an application using these specific dynamic link libraries and not being malware. They may be using these dynamic link libraries, but many times they have a lot of other dynamic link libraries loaded with them as well. But just these core base ones, usually it's malware. So this gets into one of the values of this lab is you have an environment where you can play with stuff and really, really try to learn what is going on and try different malware specimens. All right, so let's go ahead and let's get the command line invocation for our PowerShell. This is pretty wild. So I'm going to put in the first one, 4764. And you're going to see a lot of obfuscated PowerShell here. This bleeds into a lab a little bit later. We're going to be talking about, log analysis, but this is a whole bunch of PowerShell. It's basically doing all kinds of encoding to basically bypass. And you can see in the middle of it, it actually does base 64 encoding with gzip in it as well. So it's just wild. You know what we should do? I want to see something. I just want to know. Just want to know. Come on. Come on. Make it bigger. Enhance. I don't think so. Yeah, we can get it. Tweak. Oh no. I'm going to put all this in Chat GPT. Let's see what it does. All right, that looks good. All right. So let's take this whole thing and we're going to copy it like that. We've got Chat GPT around here somewhere. All right, let's just go right to the browser version. Here we go. Let's see if it tries to decode it. Very cool, you know. Nice breakdown on this. It should ask me if you want me to decode it like it did yesterday. Man, that's a pretty good write-up, actually. The huge blob is base 64, gzip compressed. I got that. That's good. It is not normal admin scripting activity. Ask it if it can decode it. So while it's thinking, I'm going to show you the alternative here real quick. So check this out. If we do that same thing with get command line, right? If I put in the netcat command line, check this out. Let's put in 7132. It's like, that's it. um, and okay, the reason why I laugh at this is I kid you not. Yesterday, one of my testers was like dealing with some AV EDR product, and he thought to himself, "What the hell? I'll just try Netcat," and Netcat totally bypassed the EDR. Um, it's almost like in the industry, so many AV EDR products are so caught up on what the cutting edge level stuff is, and they completely ignore any of these old school pieces of malware that have been around forever. So it's still going through in basic 64 decoding it, concatenations with format decoding, just doing a great job. This is actually kind of sad for me because this used to be really hard. And some of my favorite, I'm not going to give that name. Some of my favorite YouTubers, like if you're looking at like Ipsec or John Hammond, like they used to do these amazing step-by-step deobfuscation of JavaScript, deobfuscation of malware. And it was like, total wizardry, right? It's just like, we're not worthy, we're not worthy. And now, like a lot of that shit, it's just, ChatGPT just nails it. So it's double checking the logic, and then it's going to come, but just planning to evade it in the future. I think I need, oh, there we go. There it is. Oh, that's actually really good. Not bad at all. So there we got it decoded, right? So I know that that's kind of one of those things where it's like, well, is this just going to replace our jobs? You got to kind of get to this point first, right? And you got to have an idea of what you're researching and cut that time down. There are a lot of, different products out there that are like, we completely automate everything in the SOC. It's like, you really don't. It still requires a human being to be able to analyze this and have a better understanding of what actually is going on under the hood. So that's kind of fun. All right, so let's keep going. I can also get the process ID. So let me go ahead and run this real quick. Let's do that one. And then I can also run this to get the parent process on it. So we're going to go ahead and we're going to run 4764 and we can see, oh, I got to be in PowerShell. There we go. There we go. And now I can see the parent process IDs associated with what was going on. So if we look at our PowerShell, I'm going to pull this over so it's a little bit easier to see, right? If we look at PowerShell, we can see that PowerShell was begot by 6624. And where is 6624? It's up above, maybe. Okay, it's weird. But its parent process ID is 2716. I'm having the hardest time seeing things today. I think that has something to, here we go. It was started by explorer.exe, right? And if we look at netcat, netcat was invoked by netcat was invoked via cmd.exe, and cmd was invoked by explorer as well. So what is this explorer process? The explorer process actually is your GUI. It is your full Windows GUI environment. That is what you have there. So pretty cool stuff that we kind of worked through on that. Hey, we're not done. Let's do a couple of things. Let's go back to our malware again. So if we go back to the malware right here, I have this malware. We're doing stuff with it. I've been running a keystroke logger. So I can do keyscan _ dump and didn't catch any of the keystrokes. Now, why? Well, the reason why I didn't catch any keystrokes is because I'm actually running as a system process. If you look at the PowerShell and how it's being executed through a service, it's running as a system level process. So that means a problem. So we do get UID, and it's going to say I'm running NT authority system. The problem with running as NT authority system is you aren't in the kind of user land where you can pull down what keystrokes are being run. That sounds like a bit of a problem. However, you can do this. So if I do hash dump, I can actually dump the password hashes off of this computer system, which then allows me to do some really cool stuff. So let me show you what I mean by really cool stuff. So I'm going to close out some of these windows because it's getting a little bit cluttered in here. I'm going to close that out. I don't want to save that. I'm going to save this one. All right. So I want you to imagine just for a second that we have an administrator that has like a really paranoid level password. So we have a service account on the system and the administrator sets the password to that. It's a really long password. You're never going to be able to crack that password. All right. So now I'm still in. I still have malware. And if I run hash dump, you can see that the administrator's password hash has changed. It starts in the beginning of AA D3B435B5140 and then it starts over again. This is the landman hash, and that's deprecated, so it's blank for all of them. The NT password hash is right here because Windows stores two separate password hashes. So with this, you can see that we have the administrator password of password1234. And if I look at the administrator's password with a bunch of gibberish, it's FEC04E3. It's completely different. And there's no way that I'm going to be able to crack that password. I just won't. But the cool thing is I don't need to. So if I do exit -Y, like so, I close that session down, I can change the SMB pass to this one right here. I can take the administrator's password hash, just the password hash. Let's say I don't know what it is, and there's no way I would ever crack it. And I can set the SMB pass to be the hash of that user. And then I can run exploit. When I run exploit, it authenticates to the Windows computer system utilizing the password hash, which is weird because that's what it always does. A lot of people don't know this, but Microsoft Windows authentication is clear text, or very close to clear text. Whenever Windows is authenticating to another Windows computer system using NetNTL MV2, legacy LAN-MAN, NetNTL MV1, whenever it's authenticating, it actually wraps the password hash in a challenge, a 16-byte challenge that is also sent clear text. The challenge and the response are both sent in clear text, and it's easily reversible. So you can totally just gain password hashes for systems, and then you can authenticate to Windows computer systems using this as well. All right. So there's some advantages, right? When you're running a system, I have the capability of doing things like dump password hashes. Whenever I am running as a standard user, however, I have the ability to do things like run keystroke loggers. So there's always these pros or cons. It's like if you're balancing it out, it's like 6-7, right? You got to kind of choose which one is more important to you on that. All right, so that is the Windows Lab. Now I want to show you something. I talked about it yesterday. Some people run into it. I told you not to refresh your browser. And the reason why is because we're changing the administrator password, and Guacamole is trying to log in with the original password. If I refresh my browser, my Guacamole instance is dead. And that's simply because of the password being changed. So in order to fix that, all you have to do is go and destroy the lab. It takes a few moments for it to run properly. And then it's going to set us up, and then I'll just restart the lab and you get to go back to a clean slate. If you're learning IT, never underestimate the power of turning it off and on again. So I'm going to restart that so it's ready to go for the next lab. And I don't need any of this. Let's go there. I don't need that. My slides. It's really weird. All right, let me pull my slides up again. Oh, I know what happened. I closed. Hold on a second. Pause my share. Here we go. Let me open up my slides again with preview. There you go. And we go view, enter full screen. There we go. All right. So let's resume that share. All righty. So now there's some other tools that we can use that'll help with this overall process. This is a good friend of mine, Eric Conrad. He has some amazing classes at the SANS Institute, and he's released a tool called Deep Blue CLI. And Deep Blue CLI gives you the capability of doing log analysis on a Windows computer system to get more information about what is going on that computer system, which is a really super cool tool. And it all built in PowerShell, and it gives you that great flexibility. Now, we don't use Deep Blue CLI that much for the like day-to-day activities. We will use it for triage whenever we're hunting for bad things on a network. And it's also really good as a stand-in for like UEBA, because some of the analysis it does is really solid for looking at weird types of encoding that is out there. So I'll use it. We'll find things like password sprays. And then once we've identified the password spray, I'll gen up some additional PowerShell, and I will try to identify what is the actual account that is password sprayed. Deep White CLI allows you the capability of taking the hashes from sysmon log files and uploading those to something like VirusTotal, which brings us to the next lab of the day. So we're going to go ahead and we're going to go to the lab directory, and we're going to do Deep Blue CLI is the next lab. Now, this should be up and running for me right now. I got 28 seconds. And we're going to use Deep Blue CLI, and we're going to show you what AI models do in EDRs actually, and in like log analysis systems. What are the types of oddities that they're looking for in terms of like password spray attacks and different types of encoding? If you remember in the last lab, the PowerShell had a lot of really wicked encoding going on, and we're going to show you how you can detect that type of encoding and deal with it. All right, so that's the lab. I'm going to paste this in. Oh, it looks like Jesse already got it. Got it. We got to make sure that we start both those virtual machines. I'm going to connect in, and let's get rolling. For this lab, let's go ahead. This one's only like 15 minutes, and then I'm going to do the walkthrough, and then we'll get to a break very shortly after. So, Daryl, let's set the clock for 15 minutes, sir. Yeah, totally legit commands running here in our Deep Blue CLI lab. So let's go ahead and open up the PowerShell. There we go. And we're going to CD into Intro Labs. that. Then we're going to CD into Deep Blue CLI. Every time I do this, I'm like, why do I have this as two separate commands? I need to merge that into the same one. Just go ahead and do that at some point. We're going to set the execution policy to unrestricted.
Hey, John, your screen share is paused.
I'll just run it for all. Let's just do that. That's good. You can't see? Oh, I got to resume. There we go. All right. So sorry about that. We are sharing screens now. All right. So we got that. I just CD'd into the directory, set the execution policy to unrestricted, and then we're going to run it against the new user security EVTX file to kind of look at new users. And we got some weird things going on here. We've added this user to the local administrators group, and I'm just going to say that's weird. We got a username of a dash. That's strange. But what's really weird is if you look, we have this user right here, IE user, and we have the exact same SID and RID associated with that user. So we're basically creating an account and giving it a strange name and adding it to the administrators group on that, which is kind of cool to be able to look at that through the event logs, which is kind of a cool little obfuscation technique. And that also gets into something attackers are trying to do. Attackers don't want to always use malware. I think the amount of times that malware is being used in most breaches, according to like Mandiant reports and different reports that you see from things like Verizon, is now like in the 30s. So malware is still used a lot, but it's really coming down to identity, gaining access to systems, and then being able to persist by using existing accounts as well. Password guessing, once again, we're trying to get access to those credentials because that identity is so critical to everything that we're doing. So we want to get access to cred. So we're going to do a password guess attack. Now, a password guess attack is a type of attack where you are basically trying multiple user accounts with a single password. And you're going to see this show up here in a couple of minutes, but yeah, password guess attack. So a couple of moments going to come back and you're going to see that this one account is trying to log in to multiple different user accounts. You're going to see that the guessing account is coming from Josh Wright's account, and this is the desktop that's launching the attack against it. Actually, I got ahead of myself. Password guessing is going after one user account. My bad. So they're trying to guess the password for the administrator account. Now, this one's actually interesting because the administrator account can't be logged into remotely via SMB. The only way that you can attempt to log into the administrator account is either by sitting directly at the keyboard or through remote desktop protocol. So that's interesting. That tells me it's probably some type of RDP attack that we did. So I got password guessing and password spraying confused. Here we go. This is the password spray attack. So this is where the Josh Wright account is trying to authenticate, and the system that the Josh Wright account is on is trying to authenticate to all of these other user accounts in this system. This is interesting because the one up above, where you're trying to do a password guess against a user account, will run into likelihood of actually locking that account out. If we do a password spray account, password spraying being different, we're not really failing to log in more than once, maybe twice, maybe 3 times a lady against these user accounts, but we're trying to stay underneath that account lockout threshold of being detected and having people freak out whenever that happens. Now we'll get to the invoke obfuscation. And hopefully you guys had some fun with this with ChatGPT, talking about all these different types of obfuscation. And this is cool because it's basically PowerShell running through invoke obfuscation in multiple different ways. Invoke obfuscation is just another tool that you can use. So if we're looking at the first one, it's just simple PowerShell. And this one right here with all of this, like this blank space and spaces, is just trying to pad the attack as much as they possibly can to try to roll off the buffer as far as being detected. Then we have each of the individual characters. They're defining each of the characters. So it's like char 73, character 69, character 88. If you look at man ASCII, it'll go through and it will tell you what each of these characters converts to. So that's one way that you can actually do it as well. If I scroll down, that's just weird. And this one and the binary one is just very, very strange, but they both work. And this gets into some weird things with AI code. AI has the capability of coding in like weird ways that human beings can't understand or even read. And this is just one way of obfuscating that code. This is the same thing as above, but instead of defining each one of the characters one at a time, we're going through and we're putting them into an array. And then we're basically doing that character array. And then we have base 64 encoding again showing up. And this one's binary encoding. So a lot of really creative ways to kind of obfuscate what is actually going on. And Deep Blue CLI does a good job at kind of decoding that, or at least identifying, sorry, not decoding, does a good job of identifying it and saying this is not normal PowerShell for what you would expect to see on a system on that as well. All right, so let's move into server analysis. Then we got another lab starting up here in just a couple of minutes. So if we're looking at servers, right, we have a lot of weirdness and discrepancies in the way that servers work. And this gets into, I did a LinkedIn newsletter, if somebody can find it. I was called it the Coming SaaS Apocalypse. And the point of the Coming SaaS Apocalypse newsletter that I put out is we are very quickly getting to the point where anyone can go through and create a product from scratch. So we have like Freshdesk, right? So Freshdesk goes through and, you know, they basically are a ticketing system and they just quadrupled their pricing on us. And I'm like, this is literally something that I can recreate with Claude and I can do it in a week with a resource to be able to do that. And the problem that kind of gets to is now all of a sudden you're going to have tons of applications that are vibe coded, right? They're going to go through and they're going to have all of these different vibe coded applications. And the logging associated with these applications may be really hit or miss. And if we're dealing with like enterprise apps that are well known, like if we're dealing with Apache or IIS or any of those things, yeah, we can actually look at where the logs exist because ultimately logs are the eyes and the ears for what we see as SOC analysts and as threat hunters. So in this one, I can look at the access log. I also want to look at error logs, right? What errors are being generated? Because whenever an attacker is coming at your environment and doing all of these different things, you totally have the capability to generate a large number of errors as an attacker going against a system as well. Authentication logs. Yeah, we want to see the authentication. So this one, you can see that someone has multiple failed login attempts to become root on this system. And then finally, they're successful. And we have to look at lots of the different logs, a lot of the different log lines to be able to come to that determination. Now, if you want to learn, and I strongly encourage this for a lot of you that are SOC analysts and you get overwhelmed and you start thinking to yourself, how do I learn? How do I get set up for a job interview? If at the end and they ask me anything you want me to, I can talk about how you can make your resume pop really, really strongly. Jason Blanchard has a great webcast called How to Job Hunt Like a Hacker. You should all go check it out. It is phenomenal. But I have something that I add to it. One of the things that I add to it is if we look at the technologies that a company has, you can learn and become familiar with those technologies and the security relevant configurations by looking at the CIS benchmarks. The CIS benchmarks have these amazing guides for all the security relevant configurations where the logs exist for a wide variety of different operating systems and different network appliances and different applications, cloud and on-prem. And you can learn how to do all of that on your own. Now, ultimately, what you're looking for is you're looking for like, what are key configs and where are they located? What are the key processes that should exist on that system? Where does it store user information? What are the core ports that would be open on that particular system? And where do we get the logs, right? The logs are absolutely critical for you to be able to see what is actively going on. Now, I say here, this will make you, yeah, that's the post right there. I say that this will make you an Infosec Tyrannosaurus Rex. And this is literally how I learned enterprise security. When I was working in Accenture and I was at the Department of Interior during the lawsuit Cobell versus Norton, Cobell versus the Department of Interior, I had a ton of people that were coming to me because they thought I was an expert. And they were like, okay, well, tomorrow we're going to have a meeting on how to secure Exchange. And I would go to the SANS secure configuration guides, which became the CIS hardening guides. And I would learn like the night before how to harden a Windows system, how to harden a web server, how to harden an Exchange server. And I wasn't sleeping a lot, but people thought that I was absolutely an expert in all things. And literally, I was just flying by the seat of my pants, going through and just looking at all these guides on how to harden things. And that really is one of the steps that I became me doing these things as well. So an example walkthrough would be like PostgreSQL. You may not run this at work, but it's absolutely a database that you will see in your career, right? And I just want to show you kind of how some of these things show up and how you can read them into being important and how you can use them to learn as well. So here's a user example. They have this nice description. With respect to PostgreSQL administrative SQL commands, only super users should have elevated privileges. Awesome. But then they give you the commands that you can run on a PostgreSQL database to identify if there's any high-level users, right? So I can run who am I, and I can go PSQL CDU Postgres, who has that role. And it says that the people that have that role are the super user account, or sorry, the Postgres account has the super user account, create role, create DB, replication, and bypass RLS. But that makes sense. If I run this again and I see an app user, let's say a web app user, and has all those permissions, there's a very strong possibility that there's an overprivileged account on this computer. Ports and services, I can go through the guide, and it's like, here's the config that we would have. I can run this command, get the config out of this file, and I can see whether or not what port it's on, 5432, whether or not it's requiring SSL TLS. All right, so that brings us to our next lab. Go ahead and close that out. We're going to do firewall log analysis. So let's go to that. Firewall log review right here. Let me post in which one we are doing. All right, so great. I just told you. Here's where the logs are. How do you parse logs for random servers, right? So I tried to think of like some of the logs that are the biggest pain in the ass to work with. And I came to the conclusion that the logs that I think are the biggest pain in the ass to actually work with are, oops, let's go back here. There we go. Let's go view, enter full screen. Got a little bit too excited. There we go. And I came to the conclusion that if you're looking at firewall logs for a system like ASAs, adaptive security appliances are absolutely just a horrible train wreck to work with to try to figure out what is going on with those logs as well. So we're going to go ahead and we're going to have both of these set up. We got both of the VMs. We got the Windows and the Kali system. We're going to log in and we're going to go to the firewall log and we're going to do some basic grep statements, right? So if you're doing log analysis, I always start by grepping an IP address of interest. The IP address of interest would be something like, we have a system that is getting weird gerbils dancing on it, like strange gerbils that are just doing weird things. They're running. I'm not going to make a bad joke about gerbils. All right. So, and I've got this IP address, 192.168.1.6. I'm going to first make sure that my logs have that data present and accounted for. Then we're going to start carving the logs out by using grep and doing inverted greps. Like for this situation, this IP address is my edge router. I know that that's my edge router. I don't want to see any logs with my edge router. And then I can start using cut to work up and down which of the log columns and fields are interesting to me. So you're going to go through this and you're going to get down to standard beaconing level analysis by using the command line, by using our tools to be able to do it. So this particular lab is going to take you 10 minutes and then another 20. So we're going to put 30 on the clock for this total lab. All right, so let's set the clock and let's get rolling. All right, so let's carry forth. All right, so we're going to walk through this lab really, really quick. And once again, the goal of this particular lab isn't necessarily how do you parse adaptive security appliance logs. That's not the point, but rather we're using those logs to use tools like grep that will help us better understand logs of any type that you're going to encounter in your environment. So I already have my Kali system up and running. I'm going to go ahead and become root really quickly. Then I'm going to cd into the opt firewall log directory where the logs are stored. And if I do less against these ASA logs, you can see that they're kind of weird. There's definitely some strangeness about them. They have a lot of different types of logs that are loaded within the log itself. So you have like debug and notice logs, info log, debug log, notice, and there's a lot of things going on here. And the type of log that comes in changes the formatting of that log as well. So it's what we call a bad log example. Not as bad as Windows. I just want to make that clear. Windows, you're the champion. You truly suck at creating event logs. But we can get to that in a different class. So I'm going to go ahead and I'm going to grep out. I'm going to do this command in two separate steps. So I'm first going to grep out the IP address of interest in this log right here. So if I'm doing an investigation as a SOC analyst, I've got this IP address of 192.168.1.6. Something would happen. There would be a precipitating event of some type that would cause me to go into the logs to do a review. I'd make the joke about the dancing gerbil thing. That's absolutely a possibility that we would have said dancing gerbil on our computer screen. But it could be the system's running slow. It could be any number of reasons that you would start investigating this particular system. It could be something as simple as your AV alert fires and it says you need to go and investigate this system. But right now we're investigating. And the first step of what I do is I'm going to go through and I'm going to investigate and see if we have any logs associated with the system of interest. And we do. The reason why I like to start with this is because we really truly want to make sure that we aren't going to waste a whole bunch of time doing a whole bunch of log kung fu if we don't actually have the logs to begin with. So this allows us to identify that, yes, we do in fact have these logs. The other thing about these logs is you can see that I have a lot of this IP address right here. Okay. So if I were to rerun this command and grep that IP address as well, you can see that there's a tremendous amount of the logs are just the internal IP address talking to this one external IP address. The internal non-routable RFC 1918 IP address of 192.168.1.6 is talking a lot to 2423056.6. And I know what that is. That is my edge router. Remember I was talking about how we can run trace route? If I'm doing an investigation, I want to clean up the noise as much as I possibly can. And it just so happens that we have a lot of logs that are very noisy from our edge router. So what I want to do is grep out only the logs that do not have that IP address. And in grep, I do the V. So what I'm doing is I'm grepping for any line that has 192.168.1.6 from ASA logs, and then I'm grepping out, I'm removing, I don't want to see any of the lines that have 2423056.6. And this starts to kind of clean up the data a little bit. So now I'm just looking at the external communications on this one IP address of interest in our environment. And you can see we still have a lot of investigation, but just at a quick overview, I see a lot of connections going to a 13 address right here and going to an 18 address. And already right here, you can already see why these logs are very difficult to work with. We have multiple different types of like delimiters is what we call them. So we have these spaces or tabs, and then we have a slash, and then we have a colon. It's bad. We usually, whenever you're running through good logs, it should be like CSV. It should be in simple JSON, all those different things. But we're seeing multiple different ways to determine what a delineator is between those two things. But I want to start investigating that 18 and that 13 IP address. So I'm going to start by going ahead and cleaning out the columns because I want to make it so it looks cleaner for me. So There we go. I've already removed a whole bunch of data, and I can actually pull out some additional fields. Let's say I'm not interested in the date timestamp. I can remove that field. I'm not interested in the word teardown TCP connection 4. So I have teardown TCP connection 4. I can take that, clean it up a little bit more. There we go. Now I'm starting to get this data by using that grep statement, sending it through cut, and I'm just pulling out the data that's not interesting to me, something that doesn't give me, illumination as far as what I can get from these logs. And already right here, I can see some weird consistencies, right? There's a lot of like connections coming and going between 18 and 13, 18 and 13. So we got 13, 18, 13, 18, 13, 18, 13, 18, 13, 18. And it's all SSL traffic because it's port 443. And it's all going to the IP address of interest on this system as well. Also look at the durations. The durations are incredibly short, right? Like they're 1 second or right less than 1 second. And the amount of bytes is actually really consistent between 13 and 18. Let me dig in a little bit more so I can show you. All right, so if I look at just one of those IP address, and I'm specifically looking for any of the FIN packets, and the reason why I'm interested in the FIN packets is because the FIN packets are at the end of the connection. So I have all that data. I have what's the length of the connection and how much data was transferred. Now, if I just look at 13.107.237.38, look at this. Look at this. This is really super clean data, right? I have very, very, very short duration bursts, like almost like right below a second. And then there's actually some really strong consistency in the data size. We're seeing a lot of repeating characters there as well. Right, so we looked at 13. Let's dig in on 18 a little bit on that one. And I'll remove those additional columns again, just because it makes it look a little bit cleaner. There we go. And 18 is even more solid. Like once again, very, very, very tight connections. And boy, look at that data size. 1816, 1848, 1848, 1848, 1832, really tight on that data size as well. So we kind of have a bit of a pattern, but let me look at just that last column, right? Just that last column by itself. There they are. Just really, really tight pattern. Now, from a mathematical perspective, we want to ask, what is the standard deviation? What is the mode? Like, what are we looking at for the spread? And we can do this by using R script, right? So I'm going to go ahead and I'm going to put that data of all those connections, and I'm going to run it through the script. And basically, we're pulling out that specific column, and we are having R script provide us with the minimum value, the maximum value, the mean, the standard deviation, the variance. Let's see what we come up with. There we go. So the minimum value is 1816. The maximum value is 1848. The mean is 1829, and the standard deviation is only 12. That tells me that we have a very, very tight data set. And that also tells me this is probably not human traffic. This is some type of update service, and this can also be a beacon or a backdoor. And I know that it's a backdoor, right? It's just because we did this, but it is in fact a backdoor. And what are those two IP addresses, right? So we have the two IP addresses of interest, right? We have the one, which is 13, and the other one is 18. So if we look at these IP addresses, we can do some quick research, right? Do IP information. I don't like that one. Go this one maybe. Oh, there we go. I want to ads. So I can put in the IP address here, and it's going to ask me if I'm human or am I a dancer? All right. So this one is Amazon. It's CloudFront, right? So I have one in CloudFront. And if I look at the 13 IP address, right, back here, we do a search on that one. It's Microsoft. So what the hell is going on here? This is a backdoor that was created by Black Hills Information Security that we rotate through domain fronting. So domain fronting content delivery networks are used to deliver ads to people's browsers. So if you go to a website like yahoo.com, it basically will load tons of ads from a bunch of different places. So we are using the exact same CDN domain fronting capabilities that advertisers use for our command and control traffic. In this particular backdoor, it alternates communication pairs between Amazon and Microsoft. So this is kind of an example of what a really kind of more advanced backdoor would do for trying to hide in your network, right? And all of this we can identify by going into the power of using grep, right? So if you're looking like trying to figure out what the gist of this lab is, it's how do we use tools like grep and cut to parse through any type of log file that you are encountering, right? Because these tools will apply for ASA logs. They'll apply for any other text-based log that you would encounter in an environment. So that kind of helps us for that server analysis and really helps us get down to brass tacks and nails about what's going on in that log file. All right. So we're going to move on to memory forensics, and then we're going to get into a lab that takes a little while. And it takes a little while because we have to build a backend database on your system coming back from Microsoft. I'll explain what that is here in just a few minutes. But we're doing memory forensics. Now, this is different, right, from what we did with live Windows forensics. With live Windows forensics, we were running commands on a real Windows computer system that was active and running. The same thing we did with Linux. We did live Linux forensics commands while the system was running to try to identify what was going on. But there's something else that's really cool. What's really cool is most of your servers that you work with today, and many of your environments that are using VDIs, like virtual desktop environments and things like that, you're going to be running inside of a virtualization platform. And because it's a virtualization platform, that means that we can do things like snapshot the memory of systems while they're running in the cloud or in virtual machine environments. And we can do forensics analysis. And this is powerful because it allows us to do forensics analysis in such a way that the attacker doesn't even know that we're doing forensics analysis on that computer system. That's completely blind. The attacker's completely blind to it. So the main tool that we would use for this is a tool called Volatility. Volatility has a lot of standalone training. They do a lot of really good things for the community as a whole. So you should check out their website and their training and things like that as well, which is very, very cool. But we always start at the network, at least with me. I love started doing forensics investigation at the network. So with this, we run volatility and we read in a file, mem.mem, and we run netscan. Netscan is going to go through and it's going to scan through that entire memory file in an attempt to identify what network connections are open. Now, when you get to the lab in a little bit, you're going to see that the network connections repeat. And you're also going to see conflicting network connection data. Like one will say synset, the other one will say established, the other one will say closed. The reason why is because memory in Windows is an absolute nightmare. And it's not, well, it's probably one of the worst, but the way you deal with memory on a Windows computer system and even Linux computer systems is you're not overwriting and resetting memory every single time that something's freed up. You simply are marking a region of memory that is now available. That means that many times there's legacy data that is no longer valid and up to date that are still kind of sitting around in memory until something else takes its place. So you may see repeat data, and that's perfectly normal. That's just perfectly normal is what you'd see. All right, next up, process information. Remember in the Windows live forensics, we started by looking at the network connections and we moved into processes. We're doing the same thing here. We can do memdump.vmem ps list. That means it's going to go through and pull and list all of the processes. And I didn't talk about this on the previous one, but I will now. When you're doing memory analysis and you're trying to identify where things reside, things reside in different locations based on the version of Microsoft Windows and the build and the language pack. So when I identify a profile, I'm saying Windows, in this example, Windows 10 64-bit, build 1058.6. That is telling volatility exactly where it needs to go in memory from an offset perspective to start identifying these different symbols and these different references in memory where we can go through and pull it down and do analysis on it. Without this, you're never going to be able to find where things are. You're going to have to go through and do it manually. Now, some memory instances are really quick and easy to identify. If volatility will do a good job. Some it'll do a worse job. Sometimes it looks like it's working and it's really not. So this is just something to remember when you're trying to do forensics on memory. You need to be able to identify the profile. Also, sometimes students ask questions like, where do I get a memory dump? There's a lot of different memory dumping utilities that exist out there. WinPmem, you also have FTK Imager. There's tons of tools that you can use to snapshot and pull down memory. In this lab, what we're using is VMem, which is literally a snapshot file from VMware, and it can read VMware memory snapshot files as well, which I think is really, really, really super cool. All right, DLL and command line. We did this in the Windows lab as well. We went through and we were playing around, and we were looking at we're running WMIC get command line. We were also pulling down tasklist space /m space /fi double quotes. And then we go PID EQ the process ID to get the dynamic link libraries. We get all of that right here in volatility in one shot. It'll give us the command line invocation, and it'll also give us the dynamic link libraries that are loaded inside of that suspected memory analysis as well. And there's WinPmem. It looks like the volatility team has taken that over. That's really interesting. WinPmem used to be maintained by a tool called Recall from Google. And the people from Recall, was a really cool Windows forensics utility. They split off from Google and they created Volatility. Velociraptor rather. Velociraptor is now being funded by Rapid7, which is really, really cool. Question was, I don't trust my CLI skills. I can see that, right? I understand that. Honestly, just reminds me of my assembly class where the professor used only Notepad. And, oh my God. That's how I used to code. I used to start coding with just straight text editors. When I was coding and starting doing it, I would say probably in the late 90s, I started doing these and started writing code, and it literally was Notepad or WordPad. We didn't really have really good IDEs back then at all. Now, some people have been talking about GUIs versus command line, and really, I can understand and I can kind of relate for people that are like, I prefer GUIs. The problem is GUIs are not necessarily easier than command line. It's just, it appears easier. I'll give you an example. There's a quote in the industry. It says, people that think that Windows is easier than Linux, it proves they don't know very much about Linux, and then they know even less about Windows. Windows is an incredibly complicated ecosystem, especially when you're getting into registry. You're starting to get into things like PowerShell and commandlets and all the stuff that you can do. Just because it has a GUI doesn't mean it's easier. A lot of times we don't even do things with GUI, especially when we're looking at cloud security assessments. We're just using, Entra and going directly through the PowerShell command line to be able to access our cloud instances. It's just easier to do that way. So I strongly encourage you to kind of learn to embrace utilizing the command line as much as you possibly can. It's just going to make your life a lot easier as you move forward, working on these things as well. All right, so I'm going to kind of walk through the first couple of commands in this lab. Go ahead and go back to the lab directory. I should have my Kali system up and running. That looks good. And we are going to use the volatility lab, or memory analysis volatility lab. Excuse me. All right, I've got Kali up and running. I'm going to CD into the volatility 3 directory. Excuse me. And I'm going to do this first. All right, I'm running this one first because it takes a while for volatility to run. And I wanted to talk a little bit about what's actually going on in the background with volatility and kind of some historical problems that existed with Microsoft Windows and the greater community. So it used to be that, well, it does, they do now, but it used to be too. Microsoft used to release symbol lookup tables for different versions of Microsoft Windows, different language packs and service packs. And this was something that was incredibly powerful for forensics analysts, where if you were a forensics analyst and you were trying to like do some reverse engineering on like memory, you had that capability to be able to do that. And you could automatically reach back to the Microsoft kind of database and you could pull that data back in and your tool could run. However, because it was useful for things like reverse engineering, it also meant that it was very useful for people reverse engineering for exploit development as well. So Microsoft made a decision a number of years ago to shut down people's ability to be able to do lookups through Microsoft's own website of memory locations of things like network connections and process handles and things of that nature. So they shut it down. And when they did that, it kind of broke tools like volatility, tools that we use all the time for doing analysis. So there you can see it's PDB scanning is finished. We're going to start pulling down malfind data here in just a couple of seconds. It's going to start populating, but it takes a while because it's reaching back to the mothership because Microsoft opened it back up. So a lot of these tools work better now than they did in the past. So I'm going to go ahead and run NetScan too, because once again, it takes a while for these things to run and it's just good for me to get it queued up. So when we do the lab walkthrough, once we get back from the break, it'll run a little bit faster for me. It's already running a lot faster because we have that PDB scanning. So you're going to go ahead and you're going to do this lab. This lab is going to be another 40-minute lab. It's going to have 10 minutes for the break. And then we're going to spend 30 minutes doing this because there's a lot to unpack with this lab. So with that, let's take a break, get something to drink, get something to eat, and do the lab, and I'll see you on the flip side. All right, let's start the timer. See y'all. All right, we are back. So let's go through this lab. So the first thing that we do, just for the sake of expediency, I think that's good, is we run the really simple malfind command. Now, this isn't 100% effective, like it's always going to detect the malware that's on your computer system. But this is really a good first smoke test to try to figure out if there's anything that is interesting on your computer system that needs to be investigated. And one of the things that it's looking for, if you look here, it finds in this trustme.exe process, and we got the process ID of 5452, right? And I can write that down and be like, well, this is interesting. We'll put this down as 5452 is one suspect process. But it was able to identify that its memory is set up to page, execute, read, and write. Now, why exactly is that interesting, right? And the reason why this is interesting is whenever you're looking at memory on Windows, a computer system, any operating system for that matter, a lot of times that memory for an application will be read, it'll be write, or it'll be execute. It's kind of weird for an area of memory to be like kind of set up for read, write, and execute all at the exact same time. And that's just one of the characteristics that we see whenever we're dealing with malware. It also dumps some of the assembly associated with it. We have the procedure preamble here. We can look at it, but that's not the only one that has something like that. And this is one of those weird things when you're looking on when you're looking at memory. We also have this search UI that exhibits the exact same behavior. So even though I told you this is kind of strange, it is something that we do see quote unquote legitimate processes do from time to time. It is something that we encounter at Black Hills Information Security, where we see weirdness in memory. We've seen some applications that utilize a bunch of hacker style techniques for DLL, like loading, using run DLL 32 to reach out to the internet to grab DLLs and execute them in like weird sort of ActiveX control XML ways. Yeah, we see that in legitimate software. So it's just you see strangeness. That's very rare that you have any of these different things that's like, this is a smoking gun every single time. It's smoke and it needs to be followed. And that's what we're actually following here with it as well. Now, the next one is NetScan. And NetScan is the main one that I was talking about, where you will see data repeat again and again and again. And that's just because it's going to show up in multiple places in memory, and it's going to display that as it identifies it in those multiple places in memory as well. And we can see here, we've got the process associated. We've got the system process. We got services controller host, which we know does a whole bunch of things. We have DOS host, which is different than DOS boat. Two completely different things. So if I keep kind of going down, I'm going to be looking for closed or sin sent, something like that associated with it. I can see that they were running Chrome. Okay, that's fair enough. We can see that we've got Chrome running on this one. Local Security Authority subsystem service. And then right here, we can see that we have two connections. Either one of these connections is interesting, but the fact that we see them both together at the exact same time is a bit concerning. I can't believe we just got a Beer Fest reference. Beer Fest. That's great. It's hard for me to walk through the streets in Munich without thinking of Beer Fest. So if you haven't seen that movie, don't. There's a handful of really funny things in it, but I don't know if it's worth the entire movie, but maybe you should watch it. All right. So the reason why this is of interest to me is we have this trust me executable, and it's communicating outbound on port 4444. Now, once again, kind of setting this up so, I guess it's easy, right? Like we've been working with port 4444 as a default port for Metasploit. In the real world, you're going to be using things other than port 4444 if you're an attacker. You're going to be using port 80, you're going to be using 443. Hack just said 4444 is totally not suspicious at all. 666, no, that happens all the time. It happens all the time. A bunch of connections to weird islands and Virgin Islands. I don't know. It's kind of strange how that works out. Neither of those is leet. That's true. But that is the malicious process, right? Now, the next thing about this, which makes me interested, is this top line where we have this 192.168.192.145 has an established connection to 192.168.192.146. The fact that I have a suspect outward connection, and I also have another internal connection, tells me that this might be a pivot situation where this system is, of course, exploited, but it is being used as a pivot. So the attacker has control and is moving laterally off to other computer systems. At least that's the way it looks to me, right? The other thing that's really weird, and I don't know if you picked up on this, I actually think this is really cool, but I actually snapshotted this memory right in the middle of a beacon. So this is the back door that it runs for. This is Metasploit. At this particular point, Metasploit would be running for like 30 minutes, and then it would kill the connection and start up a new connection. So it was like a 30-minute beacon. And we're going to talk about beacons and frequencies and stuff like that here in just a little bit. But I managed to do this memory snapshot right as it was closing a connection, and you should see a sin sent. I think you do in here as well. So I got to say, not too shabby, if I do say so myself. And there is the sin sent. So I just thought that that was wild. So you can see we managed to do a memory capture just as that executable was beaconing. It was closing that connection. It was sending the sin sent, which brings up another kind of interesting attribute of what we're looking at here. Once again, Microsoft Windows isn't super great at like clearing memory. So it is entirely possible that you would see a scenario where you have that kind of that legacy data connection, like that closed connection and the synset, and you would see both of them in memory. It's never been really super great at cleaning out like old data connections, which is actually helpful for all of us. It is because that means, as far as we're concerned, we might find some stale like artifacts, and it would be harder for the attacker to clean up after themselves. All right, so I'm going to go through this. I'm surprised we went right to Beer Fest. I saw some Das Boat references. I didn't see any Das. Du hast, Mitch. So maybe just not into that kind of thing, which is kind of cool. Great shows. All right, getting down here. There we are. All right. So let's get into PS Tree. So I know that I have this process ID of 5452 is somewhat interesting to me. And you also saw that connection on port 445, which is a standard SMB connection between two computer systems. So if I was going to be setting that up, it would basically look like this. Like if I was an attacker, I'd be running net use, and I ran this yesterday for you. So you do net use, you would put in star, whack, whack, and then you would put in the IP address to 236.192 $. I wouldn't be connecting to myself. I would be connecting to a remote IP address whenever I do that. And then I would have a drive mounted on that. So we did that in the lab, and you could see that we could make that mounted share from yourself to yourself, kind of cross modulating with it. And you can see that connection. That is what we are seeing. Now, what is really weird about this is it was started by the system process. What's up with that? I mean, it was process ID 4 that made that connection. Why? This gets into another weird thing with Windows. There's a lot of times when you're working with a Windows system, whenever you ask it to do something, it's kind of like this operating system prophylactic. It does things for you, right? So if I say, hey, I want to mount a share, like I just ran it on the command prompt, you would think that the command prompt would be the thing that's making that connection, cmd.exe. And that, I know TechZero got the reference, but it doesn't. It's like you make the request on the command prompt and somehow it gets forwarded to the system process, and the system process makes that share connection on your behalf. That's wild, and it's not isolated. If I go into, let's say, secpoll, like if I go into secpoll on a Windows system, like if I go to local security policy, right? So if I go into local security policy, I'm not actually changing the local security policy. Like if you see me open this up, and if I change things in here, like if I do application control policies and app blocker, and I set up executable rules, and I generate the default rules, and I do all of this, I'm not making these changes. System is. The only thing that you see me do is you see me invoke privileged use to go into the local security policy, and then everything's done by system. How wild is that? Same thing here. Whenever I make a connection, I'm not making the connection. The system process is making the connection. Same thing with explorer.exe. If I double click on an executable, like if I go into something here, let's just go to the C, local disk C, and I go into intro labs here, and I just open up like Velociraptor or any of these, right? If I open up any of these, so if I try to open Netcat, gives me a command line, I'm not making that open call. Explorer is, right? And the reason why I think that this is important to understand is because if you ever end up in a situation where you have to testify in court and you see weird things, you've got to be able to explain those things. And if you can't explain those things because it's Windows being Windows and it's weird, and trust me, it's weird, then what I recommend doing is setting up an isolated system and testing your theory. So if you go to court, if they're like, well, why do we see the closed and why do we see the send? You can have a theory and you can say, well, Microsoft Windows isn't really good at doing garbage collection in memory. So you'll see stale artifacts. And that's what we're seeing here. And then you can say, I verified that in my lab by doing a series of tests to replicate the scenario, and we got the same results. So it helps you when you're trying to understand Windows as an operating system, especially when you're doing forensics analysis, to be able to come up with theories and test those theories as well. All right, so let's drop down to this 5452 process here. So we've got Chrome, we've got Chrome. We also have the cmd.exe. That's our command prompt. But here we've got trustme.exe. Now take a look at this, right? So we have trustme.exe and its parent process is Explorer, right? But then we see that trustme.exe begat cmd.exe. And then cmd.exe begat the connection host and the net command. The net command is the same thing that I just showed you a second ago, where I ran that net use command and I unfortunately deleted it. But whenever I ran net use, you can see the net command was used. And that was a child process of cmd.exe, which was a child process of trustme.exe. And now we can see that connection. We can see that connection between that share that's being accessed to another IP address on the network. And we can see that exact same process, that trustme.exe process is also communicating out from this system to the internet to a weird IP address. Did anyone do any research on that IP address that it was connecting to? Anyone look up the IP? What's the remote IP? All right, we'll see if anyone can get that. What is that remote IP address that we have there? All right, so that is our process hierarchy on that. The last one that we have is DLL list. And with DLL list, it's going to give us the command line invocation, and it's also going to give us what is the directory path. We got trustme.exe, and then the loaded dynamic link libraries that we have associated with it. And we're back to the exact same dynamic link libraries that were of interest to us when we ran the lab earlier. All right, did anybody get those IP addresses yet? Or the IP address that we are connecting? The internal one's just an internal one. Anyone? So we have this 172.104.59.60, right? So let's go ahead and let's do some research on that. So I'll go back to IP information. I'm going to put it in here. And you can see that this IP address that we had, is that the right IP address? That doesn't look right. Nope. Oh, man, it's so tweaky. Or did I paste it down here? I did paste it down here. Yes, I did paste it. All right. So you can see that that is associated with Akamai cloud technology. And I'm surprised. I thought for sure this IP must have shifted. It should have been a DigitalOcean IP address. So it looks like the ownership of that IP address has shifted. Nope, it's the wrong IP address. It should be 23.203.169.21. There we go. Now I got the right one. There we go. So let's get some information. And if we look at this, comes back to Akamai. I don't know why. All of a sudden, this must have been moved over to Akamai, but this was a DigitalOcean IP address when I said it. All right. All right. Akamai is cool too. We can use that for CDN and domain fronting, even though that is not at all what I actually did here whatsoever. All right. Does anybody have any questions on this before we go into the next section where we talk about egress traffic analysis on this? Anyone? I don't know. I disagree. Linode is not the same as DigitalOcean. Here, let me give you an example. DigitalOcean has never nuked my entire company and every op we were running at the exact same time yet. Okay. Linode did. We had full permission. We told Linode we were absolutely like completely upfront. We were pen testing. I talked to their security team. We were good. And they had a analyst that saw that we were running spear phishing campaigns and they nuked our entire company. And then they didn't turn it back on. It was really frustrating to me on that. So we moved over to DigitalOcean on that as well. All right. What do you think of abuse? I just use whatever I can use. I do Shodan and all kinds of different things whenever I'm moving around. In this class, I just grabbed something on that as well. All right. No. So if we're looking at this, even though I just closed it, if we're looking at it, the PID is the process ID. The PPID is the parent process ID. So here you can see that we have the trustme.exe's parent process ID is explorer.exe. It's explorer.exe. So that is the parent process ID associated with it. All right. Any other questions on this? I got a bunch of people. We got Seamus, we got Digital Orokami, and we have Jennifer S. rather, is talking. I'm losing my voice. I don't know what's going on. Need to go get some hot water here. It can have issues from time to time on the network PIDs, depending on the specific version of Windows and whether or not there's good symbol lookup table information that it's pulling down from Microsoft. So if you remember at the beginning of this lab, it takes a long time to run. That's because your system's reaching out to Microsoft. It's identifying what version of Windows it is, and it's pulling back that symbol lookup table to know where to look for things. And sometimes you can have issues with that as well. Can you explain which flags you can spot by looking at the DLL output? Those dynamic link libraries resonating. If we look at those dynamic link libraries, we have the Windows on Windows DLL, the Windows on Windows 64 Win, 64 CPU. If you remember, if we go back to the Windows lab, right, where we did the Windows command line, and we looked at the dynamic link libraries that were generated by Metasploit, we see those exact same dynamic link libraries. Those are the most basic dynamic link libraries that you would need for a standalone piece of malware to run on your computer system. Now, I want to make it clear there are other types of malware that can inject into the browser, that can inject into other processes and run as a parasite process. In Metasploit, we can do things like migrate, where we can migrate into another process. Totally can do that. But as far as standalone, those are the core dynamic link libraries that you would need resonating for it to run. Does that make sense? Can we use our own Kali VM? You sure can if you want to. It won't be connected to this Windows. You'd have to stand up your own environment with your own stuff. And also, you have like 16 free hours of labs to be able to work with that as well. Yeah. All right. So what other questions mean malware? If you just see this collection of just these 3 or 4 dynamic link libraries, it's time to pop smoke and start, calling the Avengers. You're going to need to assemble, and you're going to have some people work on this. No question. No question at all. Jennifer's still typing. Do one more question, and then we're going to get into the next lab because there is yet another lab. Okay. Okay. So check this out. Jennifer just brought up a really good thing that I thought was awesome. Timestamps would be able to help pinpoint those processes. There's a really cool module that exists in Metasploit called Timestamp. And timestamp allows you to mess with the timestamps associated with modified access created and executed values of your malware. So that's pretty wild that it has this type of capability built into it as well. So good question. Damn. I don't know about you, Jesse, but we haven't heard that question. That was pretty good. I like that when people ask for new things on that. Yeah. Well, it doesn't happen all the time. Don't worry, Brick. It doesn't happen all the time. It's just something that they can do. They absolutely have that capability. All right. So let's set up on our next lab. So you remember we did that log analysis lab where we went through and we were analyzing the firewall log. You remember that from like an hour ago? Good times. Good times. At any rate, did you notice how that sucked? That wasn't fun. We were using grep and we were using cut to be able to carve through a file to pull out information that is relevant to us when we're looking for potential anomalies in a log file. And cut and grep are absolutely going to be your tools of choice to be able to parse through any text-based log output. But that whole thing of looking for timing and frequency and doing analysis, yeah, that's hard. And doing it by hand and doing it with Bash may not be practical at all if you're working with a large enough environment to be able to do that. So to that end, we have a tool that we've released at Black Hills Information Security called AC Hunter, or Active Countermeasures is the name of the company. So we're going to get you familiar with AC Hunter 2. And this is going to be a tool that we are going to be releasing another community edition. We currently have Rita Community Edition is part of this total package. You can download it as well. But this tool is designed to automatically do that type of beaconing type detection that we did in that previous lab for you. So you're going to all connect to the same IP address, God help me, and you're all going to log in with the same credentials. There's no way this can end poorly. So we're all going to log in with the credentials demo.acm.re. There we go. And then we got thread hunt at Mile High. And log in. And I'm not sure, Jesse, but I think this is the first time I've done this lab for a pay what you can class. I did it at Mile High. I don't think I've done it yet with the new version of AC Hunter. But what we're going to do is we're going to introduce you to a number of different like command and control frameworks, malware specimens that are out there that you can play with, right? So we're going to look at DNSCat2, which is a DNS backdoor. You're going to select the domain r-1x.com, and you're going to look at the data associated with the you're going to look at the data that is the fully qualified domain name, and you can actually look at that lookup data inside of this. Then we're going to do asyncrat, and we're going to look at the connection to 172.208.51.75. And you're going to look at a really good frequency distribution. Okay, I might have done it then. Okay, cool. But we've got the connection dispersion, the data dispersion, the connections over time. And then we're going to ask you some questions, right? And I want you to treat this as a challenge. And we're going to take this all the way to the end of today. And then we're going to do the walkthrough tomorrow morning. So we're going to go straight into the Ask Me Anything at the end of class today. So that'll be in like 33 minutes. So if we want to set the timer and kick it off, Daryl, let's set it for like 32, 33 minutes and start it. So we can have the lab end at the bottom of the hour. But we will go through this and I will answer all of the questions on this. Yeah, it is not in the VM. We're actually doing this directly in the open interwebs. But you have these questions in the asyncrat database. What are data set? What is the connection interval for 192.168.100.136? What is the dispersion? In the xenorat dataset, what is the connection interval for 172.208.51.75? How is it different from asyncrat? For the DNSCat2 dataset, what domain has the highest lookup count? Who's doing the lookups? What does this DNS lookup look like? Why are there random strings with that? In the what time database, what is the fully qualified domain name for the C2 server? In the Phystatic2 dataset, we have issues with the MIME data. What is the issue with the user agent string? And hint, hover over the I for more information. So with that, let's get it rolling. I'll see you in 32 minutes and 58 seconds. All right, we are back, and we are back with the Ask Me Anything portion of today's program. So we had one question I thought that was pretty good. It feels more like red team work. SOC is very much related to blue and red team, and that is a true statement. If you're looking at to be really, really good at doing SOC work, you have to understand vulnerabilities. You have to understand defenses. You have to understand attack methodologies, attack paths, and then how to identify them, which is an inherently forensics-based engagement. And that's one of my concerns about SOC work. Is a lot of times people are like, well, SOC work is just entry level security, and it really isn't. At least it shouldn't have been. I just think it I think, okay, so look, the reason why I think it ended up as entry level is from a day-to-day operations perspective, it is very much like sit, watch the dashboard, wait for alerts, react to alerts. And in that light, it looks like it's very junior level work, but whenever things go sideways, and they always go sideways, the level of skill that's required to actually handle it goes up exponentially. So yeah, it does feel that way from time to time on that as well. Will I ever manage to get myself into Megan's good books? And if so, will it be measured in decades?
Listen, he's already in my good books. He
Yeah.
he likes to jab, and I like to jab back. It's a symbiotically sarcastic relationship.
I'm going to be honest with you. If Megan is angry with you, you'll know it.
Yeah. Yeah.
It's not,
I don't have a good poker face.
Yeah, there you go. So what other questions do you guys have for me? Got some people typing. Is BHIS integrating specific AI into its operations or user preferences? Is this something that is in the works? Yes, we are heavily using AI for the, not want to say red teaming per se, but external network penetration testing. We are heavily using AI for continuous penetration testing, and we are very heavily using AI in our SOC. Specifically, how we're doing it from our workflow perspective is whenever we're doing like an external security assessment, we kick off a series of agents to do a lot of the recon and set up. Well, we did the whole Opus thing. Well, I'll talk about that here in a second, resonating. But we set up a series of agents and they go through, they do the recon, they do the port scanning, they do the discovery, and all of those tools from vulnerability analysis using nuclei, Nabu for port scanning, doing subdomain brute forcing, identifying all these different things and a bunch of custom stuff is triggered by the AI agents. Then they pull the results, they analyze the results, they cross-reference the results, and then they elevate it to an analyst for the actual exploitation in many situations. And to give you an idea of how this actually works in the real world, a number of our customers have a ton of exposed APIs. And if you try to connect to the API, it just comes back with like, hello. And that's it. That's all it says. It doesn't say anything other than one word, or sometimes it says 404 not found, and that's it. The AI agents do things like see that and then basically try to do brute force enumeration to identify exactly what type of API it is, what is the framework, what are the default credentials, and then finding those credentials. So that's in the offensive side. Still very much have humans in the loop. We are not getting rid of humans at Black Hills Information Security, although I have my days, Megan. I have my days. You know, there are some days where it's like maybe I could replace certain people with just AI. Maybe that would be a thing. But on the defensive side, we're using Lima Charlie, and then we're using Tines, and we're generating a whole bunch of automation and workflows for any time that there's an alert that's generated. How does it research that alert? How does it take that data that it receives apart? How does it parse that data? How does it analyze that data, elevate it to an analyst to be able to make a determination as far as what to do moving forward? And so, yeah, we're using it very, very heavily in what we're doing. What about AI should you be learning? Oh, wait a minute. I'm a little bit behind here. Oh my gosh. Did you set up your own Opus with the recent leaks? No, we have other things that we're using in Bedrock, but we did create our own Opus just for fun. That was kind of fun to do that. Are we going to go over the lab answers? We will tomorrow morning. We will absolutely do that tomorrow morning. Would it be a good reading material that could be complementary to this course and take it further? I don't know. You can get read like Windows Internals by Mark Rosanovich. All kinds of, you know what? Just stick with the class. There's a lot of different reading materials, but we have all kinds of stuff in our Pay What You Can training. After that, I tell people all the time, find what your heart is like gravitating towards, and do that, move towards that as your space that you want to kind of move to. So if it's offensive, lean towards the offensive. If it's defensive, then you want to be able to move to the defensive side on that one as well. All right. Next one. SOC is not entry level. Are there any fields where we practice all of the things that we learn? And really, SOC is where it's at. That is absolute truth when you're looking into how we analyze things. This is built for SOC. And that's why, if you look at it, we have a whole crap ton of different things that we are covering in this class. And it's a very wide like space of things to cover. Is this opening? There we go. That's better. All right. Can you join as a junior analyst? You can in a lot of these places, but a tremendous amount of companies, it's like this really shitty dilemma that's in the space right now, where like, this is a junior level position. You must have 10 years of development experience and 15 years of IR. And it's like, that's not junior, man. I don't know what they're going here. Yeah. Used to talk about the four-way handshake as opposed to the three-way handshake. So no, so if you look at RFC 793, and I've got that right here. This is what describes the TCP/IP or TCP/IP packet. If you actually look at what it actually talks about here, way back in 1981, when they were describing it, they actually described it as a four-way handshake. So let me see if I can bring it up and I could show it to you.
Daryl, are you showing a screen? There we go.
It looks like that is being shared right now. At any rate. So basically, the four-way handshake, and I'm scrolling, it's in here somewhere. I just can't remember where it is. But the four-way handshake is what is described in this RFC. Because if you remember, if I send you a SYN packet, how do you respond? If the port's open, you respond back with a SYN ACK. Those don't have to be in the same packet. So if I'm trying to communicate with you and I send you a SYN and you respond back with a SYN and then a separate ACK, then it will allow that communication to go through. So when you're looking at it, it actually describes a four-way handshake, but every operating system takes that SYN and ACK and combines it into one packet. So that is the difference between the TCP/IP three-way handshake and the TCP/IP four-way handshake, is what they have there. So that's the history of that. I am the sole security person at my MSP, and I'm looking for tips and tricks to be successful. Since I'm essentially creating a position from scratch, I don't have a go-to person to bounce things off of. Tatanka, you're in the right place. Like, hang out here with us on these Discord servers that we have. The other place I'd recommend you go to is I would recommend I got your name wrong and I'm apologizing. I would recommend going to Cybercall. Start subscribing and going to the Cybercall every week with Andrew Morgan, and you're going to get into a community of great MSPs out there as well. No. Printed out yellow, green Infosec survival guides. Oh, Brick, are you in the US? Get with Megan. We'll ship you them. Okay. We'll ship you a bunch of stuff. Just don't burn a printer out, because printer, that ink is precious.
Yeah.
Every drop of ink is precious.
Send me a DM.
Okay. Get SIDS. That's cool. I like that one. I might just add that in. That's really cool. Let me take that note. Oh, come on. Copy and paste. Fail me. All right. I'm adding that in now. There we go. All right. Thank you. Thank you, S3CP1VP. All right. Do I think that AI is taking over junior pen testing task? No, I don't. I don't. I still think that there's a lot of room for understanding core fundamentals and the creativity. That's the thing, right? AI is just a great big huge plagiarism engine. It just is. So when we're looking at this, we've got to understand at that point that it's really good at doing a lot of things that are repeatable tasks. And honestly, that's not what you want to be doing in your job. You want to be doing the creative things. I do think it's accelerating what you see and how you interact with your environment, and that is great. But don't look at it that way. I strongly recommend you look at it as, you have to learn how to make these tools work for you. They are tools, and it's just a matter of creativity at that point. Any resources you can recommend for IoT hacking? We don't have an IoT hacking class, or we do actually. We have
do,
the
yeah,
one.
but it's at Wild West Hackin' Fest.
Yes,
And you
it's at
have to
Wild
be
West.
there in person.
Yep. So check that one out. Got the Blue Book. People are talking about those. Infosec survival guides. You mentioned some of the things for resume. Oh, okay, cool. So let's do that. So I'm gonna go to monster.com. So go to monster.com. I'm gonna put in a location of Denver because I know the area. And I'm gonna do a search. Let's just look for security roles. Um, uh,
That's crazy. When you typed in SOC, it was
yeah, I was pulling
not
up
that at all.
So let's say I want to find a SOC job in Denver, Colorado. All right, do that. That's good. We got a security operations manager, officer, scheduler, officer, program manager, sales manager, business development. I'll just go to security operations specialist. Let's go with that one. All right, so this is in Marcon Incorporated in Aurora, Colorado. The pay is okay for Denver. That's kind of an expensive place to live. But they're looking for somebody in Colorado Springs. So we got a security. Actually, this looks like construction. Oh, no, here we go. Data networks, space launch vehicles. All right, awesome. This sounds like a cool. This is a
But
nightmare.
it looks like they have to have a current top secret clearance.
TSSCI.
Yeah.
That's a really low pay scale for a TSSCI.
Yeah. They probably want entry level with the CISSP and 30 years of experience.
Have any analysts? Manager. This isn't going good. Screw it. We're gonna do this.
One day people will be able to, we're going to come together with HR and help them write actual good job posts. Maybe go to Indeed instead. Maybe that one's better.
I got this one. We got First Western. Okay. Let's do that. So an information security engineer, 96 to 155. They're in Denver. It's full time, and they're looking for a hands-on security engineer, dynamic environments. They excel at partnering and all of this stuff. What you'll do, and we're not getting a lot of technologies on this one. Down here, bachelor's degree, 5 to 7 years, network administrator, identity and access management, PAM, role-based access control, single sign-on, MFA, DHCP routing. All right, this is the perfect level of just really crappy job posting. All right. And this is exactly what I was looking for. All right. So I want you to notice that this particular job role, we don't mention any like specific technologies. We don't mention anything in it. Like, they're saying next generation firewall. Well, which next generation firewall are they using? VPN, which VPN are they using? So that's kind of a bunch of interesting things that we can find out, right? So if I want to apply for this position, I need to find out as much as I possibly can about what they're using at, what is it? First Western Bank? Is that who they are? First Western Trust. All right. So what I want to do is I'm going to do recon and job hunt like a hacker. Okay. So I'm going to first try to find their website. So I'm going to go to First Western Trust, and it's myfw.com. All right, so I'm going to go site colon my first, let's go like that. Get this cleaned up a little bit. All right. So I'm going to try to find out as much as I possibly can. We have my firstw.com. Not getting a lot. I'm trying to see if there's anything like VPN, any of those different things. But looks like they pull it all into the exact same. Let's jump way ahead. Exact same. Not getting a lot of technology profile on this. That's okay. So usually you'd be looking for like VPN, you'd be looking for a bunch of different technologies that they would be using based on the domains that they have. Like I'm trying to see if they have any sort of, man, they're indexed to the nines on Google. Oh, there we go. We've got mortgage, My First Western. We've got resources. Let's do minus mortgage. I'll just keep doing this. Okay. I think I got enough now to work with this, but I'm not getting a lot from them at all, which is fine. That doesn't bother me at all. They also have info. I'm going to throw this over there. And oh, here we go. Secure. That's great. And we got the bank login information. So I was able to pull down some websites. We have the main website. We have mortgage firstwestern, myfirstwestern.com. We have the resources, which is kind of dead. There's not a lot going on here. Let's try to go back to home. Blow that away. That doesn't get us anything. That's good. Can accept these cookies. We got info, myfirstwestern.com. Got an event they're doing. And then we have the actual secure login associated with this as well. Okay, so now what I'm going to do is I'm going to do built with. And I'm going to try to identify what is the technology that they're using at these different things at myfirstwestern.com. And I am going to put in one first, start that out. Choose the rabbits. Choose the wabbit. Choose the wabbit. There we go. I'm going to open up a couple more. There we go. And we're going to put in mortgage. And then we're going to do resources. There we go. All right, so now we're building up that technology profile. So if I'm looking at these at this particular company and I want to apply and I want to be able to do something that kind of pops, I want to be able to look at the technology so I can start to understand that technology to be able to better tune my resume to go to work to do security with these guys. So they use HubSpot. I might do some research on like HubSpot security, things like that. But the widgets, they're using Smush Pro, Crux, Common Crawl, Cookie Yes, Privacy. Okay, so it looks like they're using Google. So they're definitely using Google Cloud Compute at this particular company. So that's somewhat helpful. So I might want to go into the CIS hardening guide. So I go to CIS like so. And then I can get these benchmarks and I can start looking at benchmarks for things like Google Cloud Compute because it looks like they're using that. They're using Slack and WordPress. I don't know if they have
It
that.
looked like I saw Cloudflare too.
You did see Cloudflare?
I thought I saw it.
Okay. But in here, they have all of these hardening guides. I don't think they have Cloudflare, but they have all these hardening guides for all the different types of technology that you can come across with these things. And then a lot of these different technologies, they have their own sort of like hardening guides, like how to harden Yoast or things like that. So you can actually put on your resume doing some research. There you are. There you got it. Cloudflare. They've got jQuery. They accept Vimeo. Did they have a WordPress one in? I bet you they do. They should if they don't. No, they don't have WordPress. That's wild. But I could look up like WordPress security and jQuery security. So you can say that you're familiar with these particular technologies as it relates to your overall resume. Now, that doesn't necessarily mean you're going to get to the point where you are going to become an expert, but you damn well better at least read some of the guides if you're going to put it on your resume so you can at least speak to it. They're also running Barracuda. Dun, 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 dun. So they're running that as their firewall. And they're using Office 365. All right, so here's what we got. We know that they're using Google Cloud Compute for some of their services. They're an Office 365 shop, and they're using Azure, and they've got Barracuda firewalls. All right, so we have just done a profile of some of the key security technologies that they are running on the main website for myfw.com. Let's see if there's anything different on the other one for mortgage. I expect there to be a lot of the same things, right? We've got Yoast. They got Apple compatibility. That makes sense. They're using WordPress as their content management system. So I would do some search like, so what do we have for WordPress security guides, right? So you've got different cheat sheets out there, Security Advanced Administration Handbook. So I know that they're using WordPress. I want to go into that interview, and I want to make sure that they like I've done my homework. And if they start asking me about WordPress, I can talk about WordPress backups. We can talk about how we're backing up the existing database, how we can detect and react and set up configurations to stop brute forcing attacks. There's also a whole bunch of security tools that exist for WordPress as well. So I would spend some time learning those as well. Let's see what else they got for that one. Okay, good enough. Let's go to the next one. Resources. There's a lot of the exact same technology. Once again, it's built on WordPress. They also have a bunch of like lazy sites. I don't know what the hell that is. That's interesting. Wouldn't want to look into that. But they have these technologies. So when you're creating your resume, right, we can look at the resume as far as what they have, but I know that they're running Barracuda. I know that they're running some Google Cloud Compute resources. I know that they're running WordPress. I know that they're running Office 365. I understand all of these things. So now what I can do is I can tune my resume to say I'm familiar with these technologies. So you would put in things like, are you familiar with TCP/IP? That's one of the things they mentioned up above. Yeah, you're going to mention that you're comfortable with, what is it? TCP/IP, DNS, DNH, DHCP, routing and switches, VLAN segmentation. Any of these things would be things that you would want to make sure that you're familiar with whenever you're putting it in your resume. But I would basically put in my degree at the top. I would put in my number of years of experience. I would say I understand identity and access management principles. We have, all of these role-based access control, single sign-on, multi-factor, DMZ, high availability disaster recovery, next generation firewall, network access control. I would basically say I have taken classes that cover these particular topics. You could say at anti-siphon and those types of things, but I would put it in that specific order. And then I would go into, I am familiar with the following technologies and securing those technologies. I am familiar with securing Office 365 and Entra ID environments. I am familiar with Barracuda firewalls. And if you get that interview, you damn well better have done flashcards. You've been stood up these environments where you can get WordPress, built a WordPress site, gone through and played with the security of a WordPress site. There's vulnerable WordPress sites that you can download and you can exploit. All this crap is stuff that you should do whenever you get that interview so you can jump in. Now, here's where this gets kind of weird. I do want to try one more thing real quick. Let's go to Shodan here. See what I can find on Shodan. Go to Shodan. I'm just going to do a search for their domain, see if I can find any other TLS SSL sites. No results found. Let's go here. Oops, let's do this. There we go. So now I've got the IP address of their server. Let's see what we can find with that. So we're going to Shodan, put in the IP address. There we go. Oh, dear God. I don't know what the hell's going. Okay, so holy moly. All right. So for some reason, this host, oh, this is WordPress. So their WordPress website is hosted directly in WordPress. That's great. Let's do this one. Let's go to mortgage. See if I can find some IP address somewhere that I can get some Shodan data on it. Let's go ping. That's WordPress too. So if you look, they went all in on WordPress. Bet you this one's the same. Yep, they're all in on WordPress. That's all they got going. So that's good. I mean, that kind of narrows things down. They're hosting all of their IT infrastructure on WordPress. So you would go through and you would understand this technology, you'd be ready to interview on this technology. You would be doing resources on how to secure Barracuda firewalls. You would put that in your resume. So your resume, and this is the most important thing, your resume is tailored to the job that you're going after. Okay. It is absolutely tailored to go for the job that you're going after. And if anybody asks you, like if they start asking you questions about securing Office 365, you better know the fundamentals, right? You better know the fundamentals of how to secure that stuff. And we have classes that cover a lot of these different topics. But if you get into the interview and they're like, well, how did you learn these things? I just be honest. It's like I built a home lab and I stood up my own WordPress server. I played with vulnerable WordPress servers and exploited them. Let me do. You can find vulnerable WordPress servers right here, common security vulnerabilities. Oh, here we go. Here's WordPress Scan. That's an actual tool that's designed for scanning WordPress servers, right? So you can go ahead. They got pricing. I thought they had a free solution. WP Scan. I thought they had a GitHub repository on it. But they totally have this capability for you to learn how to scan and attack WordPress servers. So now you're at the point where you go into the interview and you're like, yeah, I built my own lab. I built a WordPress server. I went and found a cheap Barracuda firewall. I've gone through and I've done all kinds of security analysis stuff that I can do on Office 365. And if you show that initiative where you're doing this stuff on your own and learning it, that really tells me that you're someone who's really driven to do these things as well. So, all right, that's it. All right, so I'm going to drop this down. Let's bring it to a close. Megan, let's take us out. So thank you, everybody. We'll see you tomorrow morning. We'll do that walkthrough.
All right. See you tomorrow, John. Okay, everyone. Have a good rest of your day and evening. Don't forget to come tomorrow and get your bingo cards. I'll explain bingo because I realized that not everybody understands how to play bingo. So I'll explain it again to those of you that may not know exactly how bingo works, but we will get the bingo card generator out first thing in the morning before we start class. I'll explain it. Then John will go into class and hopefully people will win. Somebody will win tomorrow. You have to be here to win. So you've got to stay until the end of class, but we usually end class a little early on Thursday. So it's not a full day. So hopefully that's it. Everybody, I hope you have a good evening. Daryl, it's time. Go ahead and kill it with fire. Good night, y'all.